Hey everyone, so I hope you're all having a good Thanksgiving break, and I just wanted to put up some videos for you to help you with homework 10. I know there have been a lot of questions, especially about reducibility, and so I'm going to start with number 1, and then in the next video I'm going to go into a whole lot of information about reducibility. I want to preface all this with I have 6 dogs in my house, and so all of the squeaking or barking or growling or whatever you may hear in the background is them, and everything is fine. So anyway, let's talk about number 1. So number 1 asks you to prove that equality testing for regular languages is a decidable problem. So this is our equality testing EQ, DF, that's an F, A equals, and we're going to say we have inputs A and B such that A and B are DFAs, so they represent some regular language, and we want to know if the language represented by A is the same as the language represented by B. Now, I'm not going to go into very many details about this because this is actually the whole problem is worked out in your textbook in chapter 4. And so you could go there and look at that. I will tell you that you're going to need to use complements. And you are going to need to use it's called a symmetric difference. Sorry, I had to look up the name of it. I couldn't remember. Oops. Make that a little bit smaller. Symmetric difference for the two languages. It's going to be pretty easy from there. So once you have that, basically you're going to get this language C, which is going to be, in one case, it's going to be the empty set if A and B are equal to each other, and if they are not equal to each other, it's not going to be empty. So C is either going to equal the null or the empty set, or it's going to equal something else. It's not going to equal the empty set. And I won't give you too many hints, but the thing I did want to say about this problem is that in order to do this problem, you need to do some emptiness testing on it. Emptiness testing. And so I just want to point out something about Dr. Sullivan's version of the emptiness testing that it may not have been clear when she did it in class. So Dr. Sullivan's version of the emptiness testing says E DFA equals, so you have this machine D such that D is a DFA and a language represented by D. Dr. Sullivan's version, she has it as not equal to the empty set. And that's really important. It's from Dr. Sullivan's notes from November 13th, and that's on slide 9. So you can go on Piazza and look that up. But the reason that I'm going to point that out is because it's not the emptiness testing that is used in the textbook. So the emptiness testing that's used in the textbook has a slight difference, and that is EDFA equals, I don't think they use D, I think they actually use A, but we'll stay with D. So D is a DFA, and the language represented by D is the empty set. So this right here is what you need to make sure that you look at when you are doing your homework. This was from the text. And the reason that you need to make sure that you look at that and determine which one you're going to use in your homework is because that when you put this language, C, into your emptiness testing, you want to, it's going to give you different things based on which of these two DFAs use. So if we call this number 1 and this number 2, you can use whichever one you want. I would just make it obvious in your homework which one you're using. So basically it's going to come down to, if you're using number 1, then if your EDFA accepts, you need to reject. And if your EDFA rejects, you need to accept. But if you're using number 2, the one in pink down here, then it's going to do the opposite. So your EDFA accepts, you need to accept as well. And if your EDFA rejects, then you should also reject. So just make sure that you make it clear in your homework which one you are going to use. When I write out the solutions, I will write out the solutions for both. But basically, this is the one that you're going to end up with if you use the definition of emptiness testing that's in blue. And this one is the one that you're going to use if you use the definition of emptiness testing that is in pink. So if you have any questions about how to do the actual problem itself, again, it's in the book. You should be able to read through it and understand it. If you have any questions, I will answer your questions at office hours. Just make sure that you make it very clear which of these two you're using. The first one says basically you're testing to see if D is not empty, and the second one you're testing to see if D is empty. So that's a very distinct difference. All right, I will make the video for number 2. I'll see you guys there.